Hello everyone, welcome to Raju's classes. Whenever you analyze the previous year's question sets from Aai Atc exam, you come across numerous questions from this modern physics. Especially, there are always questions from this atomic model, and whenever you are dealing with atomic model, always one particular atomic model we can't avoid, that is Bohr's atomic model. In this video, we are going to see what is Bohr's atomic model, what exactly it says, and what is the main significance of this Bohr's atomic model, and how to apply this atomic model for various problems. And especially last Aai Atc exam February 2023, they asked the questions from this particular topic. So we are going to solve that problem also. Before entering into the video, I request everyone, those who are not subscribed my channel, please subscribe it and also press the bell button so that you can get the notification whenever I release the video. Now let us enter into Bohr's atomic model. Hi guys, before entering into Bohr's atomic model, there is a small information from my side. We are conducting online classes for Aai Atc exam. Those who are interested, you can directly contact us. My contact number is in the description. Okay, now let us see what is Bohr's atomic model. Before entering into Bohr's atomic model, we should know what are the various atomic model proposed by various scientists. Okay, the first atomic model was proposed by John Dalton's atomic model, and of course it is also known as solid sphere model. Okay, and the next model was proposed by J.J. Thomson's model, and of course it is also known as plum pudding model. Okay, because based on this various names they can ask the questions in Aai Atc, so better to know this. And also the next model was proposed by Ernest Rutherford's. Okay, and this model is also known as nuclear model, and of course the modified version of this Rutherford's model is nothing but our Bohr's model. Okay, so Bohr model is nothing but the modification of nuclear model. Okay, and it is also known as planetary model. Okay, Bohr's model is also known as planetary model. Okay, next model was given by Schrödinger's. Okay, and Schrödinger gave an electron cloud model, which is also known as the quantum model, which is the foundation for the quantum mechanics. Okay, so this quantum model is quite important. And also the last model is wave mechanical model. These are the various models proposed by various scientists. Okay, now let us see what is Bohr's atomic model. As I said earlier, this Bohr's atomic model is a modified version of Rutherford's model. According to Rutherford concept, okay, the positively charged particles are in the middle and which are surrounded by the electrons. That's what Rutherford expressed. But later on, Niels Bohr, he expressed something like, electrons are coming in a fixed orbit where the positively charged particles are in the middle, which are known as nucleus. Okay, so nucleus is as a center and the electrons are coming in the fixed orbit. Okay, and this fixed orbit is the foundation for obviously, Bohr's model. Okay, so each and every fixed orbit will have its own energy level. That's what he proposed. There are many postulates related to this proposal. Okay, so each and every electron will have a fixed orbit. That is the first one. And the second thing is always the positively charged particles are in the middle and each and every orbit is having different energy levels. Okay, now let us see what are the various postulates related to this Bohr's atomic model. Okay, according to the first postulates, which already we have seen, okay, negatively charged electrons revolve around the positively charged nucleus. Okay, so electrons are revolving around the positively charged nucleus, okay, in a well-defined orbits known as shells. In a well-defined orbits known as shell. Okay, the next postulate is each circular orbit has a fixed orbital energy. There is always a fixed shell energy for each and every shell. Okay, and the third postulate is very important where he introduced the quantum number. Okay, the quantum number represents the energy levels where whenever I say n is equal to 1, n is equal to 2, these are the various energy levels. N equal to 1 in the sense it is nothing but the K shell. Okay, and of course this K shell is known as the ground state of an electron. Okay, then L, M, N. Okay, similarly here n equal to 3, n equal to 4. So each and every quantum number represents various energy levels and various shells. Okay, K shell, L shell, M shell, N shell, something like that. Okay, so these are the three main postulates. Out of that, One more postulate is also there, that is very, very important, which is talking about the energy change. Okay, so that is nothing but the fourth postulate given by Bohr's model. Okay, and according to this, and whenever an electron is moving from lower energy level to higher energy level or higher energy level to lower energy level, always there is a energy gain or energy loss. That's what he proposed. Okay, suppose if it is coming from lower energy level to higher energy level, there is always energy gain. Whenever it is coming from, okay, higher energy level to lower energy level, and always there is a energy loss. That's what he proposed. Okay, this is the fourth postulate given by Bohr's model. Okay, so now we have seen the postulates, and let us see how to apply this Bohr's model for various applications. Okay, and Bohr's also introduced one more concept called linear momentum. Let us see what it is. Okay, so whenever we see angular momentum or linear momentum of an electron, okay, suppose if I say linear momentum of an electron, okay, what is linear momentum? That is nothing but mass into velocity of an electron, mass multiplied by velocity, okay, which is nothing but m into v. This is nothing but linear momentum. Suppose if this is a nucleus, and when an electron is coming around this, suppose if I consider this is an electron, okay, this electron is coming around this nucleus, obviously the electron will have centripetal force towards the nucleus. Always there is a centripetal force. This centripetal, because without centripetal force no object can rotate, revolve. Okay, therefore always there is a centripetal or centrifugal force is needed. This force is provided by the electrostatic force between this electron neutral, because this is positive. Okay, there is an always electrostatic force which gives this centripetal force. This you should know first. Okay, because this is the fundamental of when the why the electron is coming around in a fixed orbit. This is the fundamental concept. Always there is a centripetal force which is caused by the electrostatic force between the electron and this positive charged particles. You should know this first. The second thing is, whenever I talk about momentum, always there is a radius for this. Okay, so whenever I talk about angular momentum of an electron, which is nothing but the linear momentum mv multiplied by radius. Therefore mvr is nothing but angular momentum. This is very, very important. Later on, Bohr specified one more concept for this linear momentum, L, in terms of Planck's constant. Okay, where n is the quantum number multiplied by the Planck's constant divided by 2 pi. Okay, this is very, very important. Even in the last February ATC exam, they asked the question from this particular formula. Okay, so whenever I say this n is a quantum number, h is the Planck's constant. Of course, Planck's constant we know 6.62 into 10 raised to minus 34 joule second. Okay, so based on this, h by 2 pi, okay, h by 2 pi, which is denoted by h bar, and of course this is nothing but reduced Planck's constant. This is very, very important. Reduced Planck's constant. Okay. So this reduced Planck's constant, of course the value of this one is nothing but 1.054 into 10 power minus 34. Okay, sometimes they may ask the numerical value of these constants also, so better to remember. Okay, so my dear friends, try to understand, according to Bohr's model, the angular momentum is given by mvr. The angular momentum is given by mvr. In terms of Planck's constant, it is given by L is equal to n into h bar. What is h bar? H bar is nothing but the Planck's constant divided by 2 pi, which is known as reduced Planck's constant. So based on this, in ATC you may expect the questions. Okay, so now apart from that, one more concept is there, because we know very well that the electron always behaves like a particle sometime, wave sometime. It is having both the nature. It is having particle nature as well as the wave nature. For instance, whenever I talk about dual nature of an electron, of course it behaves like a particle sometime it behaves like a wave. Okay, so whenever I say particle, obviously the mass will come to picture. Okay, whenever I say wave, and the wavelength will come to picture. Okay, so how to relate these two? Based on this, the same relation once again we can get. Okay, because conceptually we should be strong enough so that whenever they ask the questions from this atomic model, obviously you need to answer with the correct objective answer. Okay, so better to know this concept also. Also, this dual nature was very well explained by de Broglie. Okay, de Broglie. Okay, this scientist, he related the lambda with respect to the linear momentum. He said that the wavelength of an electron or whatever may be the particle is indirectly proportional to the linear momentum. Indirectly proportional to linear momentum, or in other words, he introduced a constant lambda equal to h by mv. This is the de Broglie hypothesis. Okay, so also the 2 pi r is the rotation of an electron, okay, which is always equal to n lambda. Okay, n lambda. Therefore, when we substitute this lambda value there, 2 pi r is nothing but n into h by mv, or we can say mvr. If I cross multiply, mvr is nothing but nh by 2 pi, or in other words, n into reduced Planck's constant, because h by 2 pi is nothing but, once again we are getting the same relation. So my dear friends, try to understand this concept. This is quite important in ATC exam point of view. Okay, because based on de Broglie, already in the previous sets of questions they have asked many questions. Okay, so according to de Broglie hypothesis, the wavelength is indirectly proportional to the linear momentum, mass and velocity. Okay, so whenever I say indirectly proportional, if I introduce a proportionality constant, it is nothing but h by mv. Lambda is equal to h by mv. This is nothing but the de Broglie hypothesis. So when I apply this de Broglie hypothesis for the rotation, we know very well 2 pi r equal to n lambda, and instead of lambda, if I substitute h by mv, I am getting n into h bar. mvr equal to n into h bar, the same relation which we got already, okay, using Bohr's model here. Okay, Bohr's model here, linear momentum is nothing but n into h bar. Therefore, we know very well that the linear momentum, okay, linear momentum L is nothing but mvr, which is nothing but n into h bar, or n into h by 2 pi. H bar is reduced and h is the Planck's constant. Okay, so this formula is quite important. In the February 2023 exam, in the shift 2, I guess, there was a question related to this. Now let us see what is that question. Okay, so if you see the question paper from February 2023 shift 2, the question is something like this. Consider the solar system as a large atom, the quantum number n that characterizes Earth orbit. So in this question, we are going to find out the quantum number for Earth. Okay, that is Earth quantum number. Earth's quantum number we are going to find out. N we are going to find out. Okay, and they, of course they have given the radius 1.5 into 10 power 11. Okay, and the mass they have given something like 6 into 10 power 24 kg, and they have given the velocity which is nothing but 3 into 10 power 4 meter per second. These are the data already have been given in the question paper itself. Okay, we know very well that the linear momentum formula is nothing but mvr, which is nothing but quantum number of Earth multiplied by h bar, that is reduced Planck's constant, or it is nothing but n into h by 2 pi. So we can substitute the values here. Whenever you substitute the value, m is nothing but 6 into 10 power 24. Okay, and of course velocity is nothing but 3 into 10 power 4. Okay, and we have the Earth radius 1.5 into 10 power 11, which is nothing but n into 6.62 in 10 power minus 34 divided by 2 pi. So if from this, if you substitute the value of, we get the Earth quantum number as 2.56 into 10 power 74. Therefore, option A is correct. Option A is correct. So, my dear friends, you should know how to apply the Bohr's atomic model. Okay, and based on this, always there will be questions in ATC exams. So, better to be conceptually thorough with this particular model and how to apply the formula for this particular application. So, friends, whenever you talk about applications of Bohr's model, and we should know the limitations also. Limitations also very important, because sometime in objective MCQ point of view, they can ask the questions from this limitation also. The first limitation is Zeeman effect. Okay, Zeeman effect. Okay, Bohr's atomic model does not explain about Zeeman effect. Zeeman effect is nothing but the effect of magnetic field. Effect of magnetic field on it. So it was not talking about the magnetic field effect. Okay, field effect. So this is not included in the model, and simultaneously there is one more negligence, that is nothing but Stark effect. Stark effect. So please remember, and whenever you come across the questions related to this, you should be able to recollect. Okay, Stark effect is directly relating with the electrical field. Okay, electrical field effect was not included. Okay, electrical effect was not included in this, that is Stark effect, and also it was violating Heisenberg uncertainty principle. Okay, violating Heisenberg uncertainty principle. Uncertainty principle. This is also very important. Uncertainty principle. Okay, so there are some limitations for this Bohr's model, so that also we should know. So my dear friends, I hope that this video would have been more useful for your ATC preparation, and if you find this video is useful, please give me a like, and also those who are not subscribed to my channel, please subscribe and also press the bell icon so that you can get the notification whenever I release the video. Anyway, keep on preparing. All the best my dear friends. Thank you.